Python makes it really easy when you have a sequence of values to obtain a subset of that sequence, what's known as a slice operation. In this video and the next, we're going to talk about various slicing techniques. Here we'll focus on slicing techniques for copying subsets of sequences, and those techniques will work the same way whether you're talking about lists, tuples, or strings. When you take a subset of a list, you'll get a list. When you take a subset of a string, you'll get a string. And when you take a subset of a tuple, you'll get a tuple. Now, you can also use slices to modify mutable sequences such as lists, and we'll demonstrate those techniques in the next video. So for the purpose of this discussion, we're going to work with a list called numbers containing the integers that you see here, and the data type stored within the list is somewhat irrelevant for this discussion. We happen to be using integers, but of course you could have a list of anything you want, and these slicing operations that I'm about to show you will work for all of those scenarios. Now, in the list numbers, let's demonstrate the most basic kind of a slice, which is where you specify the starting index of the slice and the one past the end index of the slice. Let's show you what I mean. So we're going to create a slice expression where we want to select elements from numbers starting from index position 2, so 0, 1, 2. We're going to start with the value 5, and in this case we'd like to go up to but not including the index 6. So up to but not including the index 6. So we've got 3, 4, 5, and then this would be the index 6. So we're basically saying that we want to select these highlighted 4 elements from the original list, and the result of this expression will be a new list containing copies of the references in the element positions 2 through 5. So that's an interesting point, because that means the new list that I get back is actually a copy of these references, and therefore both the new sublist and the original list refer to the same objects 5, 7, 11, and 13. This is the result of the expression that we just typed there, and as you can see, again, starting from index 2, we go 3, 4, 5. This is the last element of the subset or the slice, and then this is the index that we stopped counting at. So you can see we get the 4 elements up to but not including position 6 in that subset or that slice. Now, interestingly, when you're defining slices, you don't always have to put numbers on both sides of that colon operation. So for example, consider this expression, numbers colon 6, in which we imply that we want to start from the beginning of the list and take the subset up to but not including index position 6. So implicitly, Python will insert a 0 before that colon, which is the first index in the list, and I will get everything up to but not including index position 6. So this expression that we just typed here is equivalent to saying 0 colon 6. So if you know that you always want to start from the beginning, you can leave out the starting index number and simply provide a colon and the ending index number, and you see we get the exact same result. Now, in a similar fashion, we can also say go all the way to the end of the list. So if we say 6 colon, that says start from index position 6 and go to the end of the list, and it will implicitly insert the length of the list for you in that case. So you can see here we get just 17 and 19, and that last expression is the equivalent of me going ahead and putting in the length of the numbers list as the second index value in that slice expression. So if I go ahead and do that, you see we get the exact same results once again. Now, it turns out that if you ever need to make a quick copy of a list, you can use a slicing operation for that by simply leaving out the indices altogether and putting a colon inside the square brackets. In this case, the interpreter is automatically going to infer 0 as the starting index and the length of the list as the ending index, and you can see we get a duplicate of the original list. Now, it's important to note that that is what we call a shallow copy. Every slice operation is a shallow copy. And what that means is we get new data structure objects, in this case new lists from the slice operations, but we don't get copies of the actual values in memory. So there's still only one object with the value 2, one object with the value 3, one object with the value 5, etc. And this new list that was just created refers to the same object containing 2 as the original list, the same object containing 3 as the original list, the same object containing 5 as the original list, etc. So it's a shallow copy operation. And in later lessons, specifically when we get to the NumPy lesson, we'll talk about deep copying, where copies of the actual values get made as well. Now, as you might expect from the range function descriptions or discussions in earlier lessons, there is also the ability to do slicing with step values. So you don't have to always select consecutive elements within your slice. So for instance, if I go ahead and write an expression like numbers : 2, the first index will be inferred to be 0. The second index will be inferred to be the length of the list numbers, and the third index to the right of the second colon is the step. So what we're saying here is, starting from the beginning of this list, going all the way through the end of the list, we want to select every second element. So we'll select the element at position 0, position 2, position 4, etc. And you can see we get 2, 5, 11, and 17 as a result of that particular slicing operation. And taking that a step further, no pun intended, we can count backwards as well. So we can say numbers sub : -1, and what this says is give me a copy of the entire list in reverse order. So we're basically counting backwards one step at a time. Now it's inferring based on the negative step that we want to start from the end of the list and work our way backwards. So you can see that this is a super quick way to get a reversed list from the original list. Now this particular one, the indices that we're getting as the defaults are a little bit different from what you might expect. So this is actually the equivalent of saying start from the last element using negative indices and go backwards up to but not including 9 prior elements. There's only 8 elements in the list, so this second value, remember, is always up to but not including that position, and then we're going to count backwards one element at a time. So this is the equivalent, and obviously that's a little bit hard to figure out, so this nice concise notation up above is the typical way in which you would reverse a list using a slicing operation. In the next video, we'll start talking about the slice operations that can modify a list.